Um, for the second part, this is exam 3 part 2. So we have import memb p. I will make subplots. So I just import next subplot, and then import the linear algebra import, so bandit. This is plot delete. So I have nx equals 49. It is like 60 minutes. Temperature, just set this is the room temperature, so nx 20. T at 0 is 50 degrees Celsius. Then alpha is 1. Dx is I'll calculate every 1 meter. Dt is measure the temperature every 1 minute. X equals np range x times dx. Then r equals to alpha times dt over 2 times dx squared. This is everything that is given. Next, I have a matrix like the A matrix. Goes to the first thing, I just zero out everything. -1. Then we have A0 and from 1 to the n equals to -r. A from 1 to -1. Actually, this is 1. No, 1. Okay. From 0 to from the first position to the last position is 1 plus 2 times r. A from 1 then -1 equals to 1 plus r. A2, the third row from beginning to -1 equals -r as well. Just see our r appear like this. Then we have B zeros and x -1 as well. Then next subplot rows is equal ones, columns equals 1. Then add scatter x equals x, y equals t. We have the name was 0 minute. Alright, this is the first temperature, the temperature, the T0. Next, I will have a B from the first to the first position to the negative, to the minus position. Exclude the last position. It would be R times T of -2 plus 1 minus 2 times R times T from 1 to -1 plus R times T from 2, go from position 2, and then I have B at 0 equals to actually let me try like this is from 1. Is that no, so we have to make from 0. Okay, then B, now I can change B at 0 equals to B0 plus R times T at 0, and then B at -1. We have B at -1 equals to R times T -1 plus we will change, instead of 1 minus 2 we have 1 minus 2R, we have 1 minus R times T -1. Actually this is -2. Okay, and then we have to add, like similar to the very left position, or like very first position, we don't have the J, like the temperature at the position to the right, to the left of that position. So in the last position, we also don't have any temperature at the on the right side of that position. So we have to add the R times T minus 1 into that position, into the B. So we have B from -0 plus R times T -1. Then we will plot, we have the temperature equals to the solve banded 1 1, and then we have A, we have B. Alright, I'll try to plot it out. Okay, so we have big dot add scatter x equals x, y equals T of 0 for, and then 49 mole equals lines. Oh, actually no, 48. I think this is not correct. X. Oh, 0 and 48 also. Hmm. 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 Okay, hold on. 50. All right, here we are. So this is this is our like the very first, like t at t equals I think it's like seconds, like the first minutes, like t, the time equals, this is n plus 1, like, so like it's 2. This is at time 1 and this is at time 2. So if I put everything into a for loop, so we can have so for I in range of 1, then n t plus 1. Okay, and we'll add, okay, and to plot it, I just like if I divided by 5 equals to 0, it would be this. Okay. No. This should change to x and then y equals t. Alright. Yeah, like it happens to me every time, and I think it because of the like my computer messed up with the like the numbers or some stuff like that. So I try, because it works well in when it's not inside of the for loop. So yeah, that's everything. Yeah, like that's everything I could do, because I have tried a lot like to figure out like why it works outside of the for loop, but it it doesn't work inside of the loop. But like uh, some people said like uh, it's just the like numerical error or something like that. So yeah, like that's what I guess, and it's that error, like it's very hard to fix. So like even the computer science students couldn't fix it. So yeah, I think like that's everything I could do.